Hey there, guys. We are back with some more decomposing fractions, and we are going to be kicking it up a notch and taking a look at a problem that's at a bit of a higher difficulty level here. So this is our 5-4 objective here, partial fractions. So essentially what we're going to be doing is taking some rational expression. You can see an example of one below, and we're going to be decomposing or pulling it apart into its initial, fix that right there, initial polynomial factors. So let's look at how we can do this, what's this going to look like, and what our end goal might be. So step one is going to be take a look at some sort of rational expression, and we want to just begin by factoring the denominator. So this is a quadratic that we're very familiar with factoring. So we're going to leave our numerator alone and simply factor this denominator into an x minus 5 and an x plus 2. Okay, that's all there is to step one. Okay. Okay. So we are going to still be following the exact same steps that we did before. That's not going to change, but there's going to be just a little bit more work to do in certain areas. So we're still going to want to start with factoring our problem. So let's take a look at what our problem here is going to be. So we're going to look at 4x squared minus 37x plus 103 divided by x cubed minus 6x squared plus 3x plus 10. All right, and what we want to look at is how can we factor this. Oops, that's not how you spell that. How can we factor this denominator? Okay. All right, so we're going to pull this off to a separate page to factor here for a moment, and then we'll come back to it. So now we can go over here and we can say, yes, I factored this. So once I factor that, I end up with this nice 4x squared minus 37x plus 103 over x cubed. Oop, nope, we factored this. That was the whole point of all that work. Okay. X minus 2, x minus 5, and x plus 1. Okay, so that was the portion that was significantly different from what we saw in the previous video. Okay, the rest of this should be very similar, but just with a small amount of additional work here. Overall problem. All right. So let's see here, x cubed minus 6x squared plus 3x plus 10. Okay, so we're pretty comfortable factoring quadratics, but we don't really factor a lot of cubics. So what we're going to employ here is our rational root theorem. Okay, so what this simply states is if we're looking at the possible factors of this polynomial, right? So things that when I plug them in, I get 0 here. They're all going to be of the form of plus or minus factors of our constant. So this last term here, 10, divided by factors of our leading coefficient. All right, so that's, in this case, 1. So let's take a look at these. So we're going to have plus or minus. I'm going to write this in kind of a condensed version because this is just our side work, nothing fancy. So the factors of 10, we have 10, 5, 2, and 1, and factors of 1 are just 1. All right, so let's keep going. So that means that all of the potential roots here are plus or minus 10, plus or minus 5, plus or minus 2. We'll actually write those in here. And plus or minus 1. So this is not saying that these all are factors. It's saying that if we have a factor, it's one of these guys. So we want to test and find a factor here so that we can use that to factor and find the rest of our factors, okay? So basically, you just test them, right? Plug them in. Do you get 0? If you do, you're good to go. So I'm going to test the one that works. So let's test 2. So if we take 2 cubed minus 6 times 2 squared plus 3 times 2 plus 10. We get 0. We're good to go. Choose a factor. All right. So what that means is at some point when x equals 2, right, this is a factor. So let's kind of pull that over, right? X minus 2 equals 0. We're used to seeing something like this when we're solving for the zeros. And this x minus 2 is our first binomial factor of this trinomial. So I'm going to go over here and say, all right, well, this is x minus 2, right, times some other thing that we have to figure out. Okay, we're going to figure out that some other thing using synthetic division. Okay, so I'm going to divide my polynomial by a factor that I know works, right? And we divide it by the 0, so we do divide it by a positive 2. All right, so setting up synthetic division. If you're not comfortable with synthetic division, there is a synthetic division review video and practice on our playlist. Go check that out. All right, so my factor goes out front there, my 0, and I'm going to just write my coefficients. So we got 1, -6, 3, and 10. Make sure to put a 0 if you're skipping a degree. Okay, so 1 gets pulled down, multiplied by the 2. We add, okay, again, multiply by the 2. Okay, add, multiply by the 2. And very nicely, this went in evenly, which we expected because it is a factor. So if you successfully picked a factor when you do your synthetic division, you will always end up with a remainder of 0. So we had our initial factor x minus 2, and now we have this leftover polynomial after we divide that out. So if we remember, the last piece is going to be a constant, and then moving to the left, an x term, an x squared, and it increases as we go up. So we have x squared minus 4x minus 5, which happens to be a quadratic that we are capable of factoring. So finally finishing this off, we have x squared, and then this is going to factor into x minus 5, x plus 1. So all of this work here was just to factor that denominator. That was our goal. Step 2. We are going to take this rational expression with a factor denominator, and we are going to write one partial fraction for each factor where our numerators are constants. We're going to let those constants be a and b because we only have 2 factors. We would use c, d, etc. if we had more factors. Okay, so what is this going to look like? So we're going to set this equal to constant a divided by our first factor, x plus 5, plus a constant b divided by our second factor, x minus 2. All right, and that's it for step 2. So after we factor, we want to write one partial fraction for each factor with the constants a, b, and c as our numerators. So this is going to look basically the same as what we did before. So we should have a 4x squared minus 37x plus 103. We're just writing that original rational expression that we had just factored. And I just kind of fudged the order there, but it doesn't really matter because multiplication is commutative. All right, so now here's our partial fraction parts. We have a over x minus 2 plus b over x minus 5 plus c over x plus 1. Okay, and I can fix this order. It doesn't really matter, but just for the organization of our work. X minus 2, x minus 5. Okay, so that was our second step there, is just to and write that out. Okay, so where do we go from here? Whoop, too far ahead. The next thing we want to do, step 3, is we want to solve eventually for a and b, but our denominators are in the way. It's difficult for us to solve with denominators. So we're going to go kind of back to the last objective, which was solving rational equations. And we're going to do something very similar, which is multiply through by the least common denominator in order to cancel out our denominators and be able to solve. So if I'm looking at that, our least common denominator here is going to be x minus 5, x plus 2, and I have to do that on both sides. So on both sides, I'm going to multiply through by x minus 5 and x plus 2 there. Okay, so on the right-hand side, left-hand side, excuse me, that just nicely cancels out, and we are simply left with 6x minus 2. And then on the right-hand side, something slightly different happens. So this is basically created a distribution problem, and we need to take that least common denominator and multiply it to both terms inside our brackets. So when we multiply it by our first term, we can see that our x minus 5s will cancel out there, and we will be left simply with a times x plus 2. And then for our second term, this time our x plus 2s are going to cancel out, and we'll be left with b times x minus 5. Okay, now this is getting a little bit nicer and looking like we can maybe do some things to solve for a and b, those constants. All right. Okay, next step, again, this is the same. We want to kind of make this into a form that we can start working with by canceling out these denominators. And the way we do that is by multiplying through by our least common denominator. Now this problem does get a touch long when we have 3 factors, so we're just going to kind of squeeze things in here to the best of our abilities, okay? So our common denominator here is going to be x minus 2, x minus 5, x plus 1, and same over on this left-hand side. X minus 2, x minus 5, I'm going to squeeze this in, x plus 1. All right, so on the left-hand side, just as we want, the entire denominator cancels out, and we're left with that nice 4x squared minus 37x plus 103. And then when we go through the right-hand side, only one binomial cancels out each time. So in the first case, it was the x minus 2. So now we have a times x minus 5, x plus 1. If in this step you also want to multiply those binomials together, that's fine. I'm going to be doing it in 2 steps just so that everybody sees where things come from. All right, so then we're going to have b. This time the x minus 5s will cancel with each other. So we'll be left with an x minus 2, x plus 1, and then plus c times, and this time the x plus 1s. So I am running out of space. X plus 1, or nope, x, excuse me, minus 2, x minus 5. All right, so let's clean this up a little bit. Left-hand side, we can't do anything to simplify, but we can on the right-hand side. So this will become a, if I multiply those binomials, we'll get an x squared minus 4x minus 5 plus b, and if I multiply those, we'll get an x squared minus x minus 2, and then plus c times x squared minus 7x plus 10. Okay, so in our next step, we will be taking a look at solving these guys for our A, B, and C values. And if you remember, we want to use the zeros. So sometimes I go ahead and distribute and simplify it like this just because it makes it easier plugging in our X value. But if you like to see your factors separated out, go ahead and leave it like our first step. Neither is incorrect, doesn't really matter. It's just how you look at the problem better. Okay, so I'm going to leave it here. You guys decide what you want to do. So going on to the next step, I'm actually not going to use this, but if you want to, go ahead. So the next thing, so how can we find those? We do want to find these constants, and we're going to find them using the zeros of our two factors. So if we look at our two factors here, x plus 2 and x minus 5, well, this first factor, x plus 2, is going to become 0 when x equals negative 2. And this second factor, x minus 5, well, this is going to be 0 when x equals positive 5. So let's use that. So let's go ahead and let's solve first for a. Okay, so let's solve for a. Well, in order to do that, I would really like the other term, the one with b, to equal 0. And the way we're going to do that is we're going to let x equal 5, the 0 of that factor. Okay, so when we do that, what do we get? So everywhere I see an x, I'm going to substitute in a 5. So on the left-hand side, we're going to get 28. And on the right-hand side, we're going to get a times 7. And then that second part there is just 0. So we don't need to worry about writing that. We're going to finish this off, solve for a. And we're going to go ahead and get that 4 equals a. Let's do very similar solve for b. So this time I want to find b. So this time I want the other guy to be 0. So let's let x equal negative 2. So this time everywhere I see an x, we're going to substitute in a negative 2. So we'll get negative 14 equals b times negative 7. Finish solving, and we'll get 2 equals b. So now we have these constants, and we can go all the way back and substitute these into that initial part where we wrote our, okay, so let's solve for these a, b, and c. All right, so if I want to solve for a, that means I want the terms with b and c in them to become 0, essentially. So I want to look at what's in common. And this is why I tend to leave it a little bit factored out, because I can see really easily that they both have an x minus 2, which means that if x is 2, both of those terms are going to become 0 and allow me to solve for a. So over here, I'm going to let x equal 2 in order to allow that to happen. So on the left-hand side, we're going to plug in 2 for x, and we're going to get 45. And then on the right-hand side, we're going to get a times negative 9, and then just finish solving. So negative 5 equals a. All right. Now for b, I want the terms with a and c to become 0. So I'm going to kind of look at their common factor here. And I'm going to say, all right, well, they both have an x minus 5. So that means if x is 5, both of those terms become 0 and then allow me to solve for b. So everywhere I see an X, I'm going to plug in a 5. And on the left-hand side, we're going to get 18. And on the right-hand side, we're going to get B times 18, which tells us that 1 equals B. And lastly, we're going to take a look and solve for C. And we're going to see how this color shows up. Oh, it's not bad. Okay, so same thing. This time we want A and B to drop out. So their common factor here is X plus 1, which tells me that if X equals a -1, then those two terms become 0 and we can solve for C. So everywhere I see an X, plug in a -1. Do be careful about squaring negatives. Please make sure that negative squared becomes a positive number. So if you're using a calculator, which you really shouldn't be, please be careful about using parentheses. So on the left-hand side, we get 144. And on the right-hand side, we get C times 18. Solving tells us that A equals C. Okay. So we found those values, and we're going to go back and we're going to substitute them too far. So we're going to write this out. So we're going to say, hey, this original 6x minus 2 rational expression divided by x squared minus 3x minus 10. We said this was equal to some constant a, which we just found out is 4, divided by x minus 5, plus some constant b, which we just said was 2, divided by x plus 2. All right, that is our final answer. But let's check and make sure that this works. So what I'm claiming is that if I actually add these together, right, these two kind of smaller rational expressions, I should end up back at my original rational expression, right? All I did is take the original and pull it apart into two smaller pieces. So let's just double check that. We go back a slide here, we can see, hey, we added those two partial fractions. Yes, we did in fact get back to our partial fractions. So now we know that if we have the rational expression 4x squared minus 37x plus 103, all divided by that cubic that we had, x cubed minus 6x squared plus 3x plus 10, we can break that up into the partial fractions of -5 divided by x minus 2. You don't have to put these in parentheses. That's just kind of a habit I get into, just so that binomials are very clearly binomials. Plus 1 over x plus 5 plus 8 over x plus 1. Oops. This needs to be a -5. There we go. That's our actual factor. Okay, and at this point we are done. At any time that you want to check your work, go back, just like in that first video. Take this right-hand side, actually do the addition. As long as you end up with what we started, you are good to go and you've done it correctly. So we're going to end there. If you want to see more examples, go on to my Part C video where I go through additional examples of these. Otherwise, go on to your worksheet, try a couple out, and see how they go.